The diagram shows a sector of a circle with center O and radius 20 centimeter. A circle with center C and radius X lies within the sector and touches it at P, Q, and R. The angle POR is 1.2 radians. Show that X equals 7.218, correct to 3 decimal places. Okay, so we need to find the value of X, which is the radius of the circle that we see. This would also be X, the radius of the same circle. And since this is a tangent, so radius and tangent, they're perpendicular to each other. So this has to be a 90-degree angle. And same at this side, this will be a 90-degree angle. This would be X. And if we connect these these 2 points, this length would be 20 minus X. Why is that? Because this is 20, this is 20, and so would this be 20. So this is X. So the rest of it has to be 20 minus X. Okay. So now this angle will split into 2. So this would be 0.6 on both sides. Now I'm going to use this triangle and find X. So we can use sine theta. So it's sine theta equals to opposite upon hypotenuse. Now theta is 0.6. So let's replace theta with 0.6. And now we cross multiply 20 minus X times sine 0.6 equals X. Simplify this, we have 20 times sine 0.6 minus X times sine 0.6 equals X. So 20 times sine 0.6 equals, I'm moving the X term to the other side and also taking X common. So it will be X plus, 1 plus sine 0.6, which will then divide here. 1 plus sine 0.6, and let's see what do we get. Make sure that the calculator is in radians. 20 times sine 0.6 upon 1 plus sine 0.6. I've kept it sine 0.6 till the very end just to avoid premature rounding. So I'm getting 7.217527. So X is coming out to be 7.217527, which rounds off to 7.218 in 3 decimal places, as shown here. Okay. Moving on. Find the total area of the 3 parts of the sector lying outside of the circle with center O. Okay, so we need the area of, just a second. Okay, so we need this area plus this area plus this area. So this would just be sector area minus circle area. So for part 2, it's going to be the sector area, which is half r square theta minus circle area, which is pi times radius square. Radius is x 7.2175. I'm using the unrounded value and use at least 4 decimal places. Okay. This gives 76.3 centimeters square. Part 3, find the perimeter of the region OPSR, bounded by arc PSR and the lines OP and OR. Okay. So we need perimeter of this shape now, which is this side, PO, plus this side, plus this length of arc. And you're going to consider this sector to find that length of arc. Okay. Let's find uh, PO and OR first. So we're again going to use this triangle. This length came out to be 7.2175 before rounding. And this one was 20 minus R. So 20 minus answer, 12.78247. Okay, this was 20 minus x. So now it becomes 12.78247. And now you may apply Pythagoras to get PO, or you may use SOHCAHTOA or sine cos tan as well, because it's a right angle triangle. Okay, I'm going to use Pythagoras. So RPO and RO would come out to be a square root 12.78247 squared minus 7.2175 squared. So square root answer squared minus 7.2175 squared, 10.54. 98. Okay, so the perimeter of this region is going to be 2 times 10.5498 plus this length of arc, which it has a radius of 7.2159, 7.2175, sorry, and a theta of, okay, we'll have to figure out that theta. So we have a quadrilateral here. Two of the angles are 90 and 90 in degrees, and the sum of four angles would be 360. So from 360, let's subtract 90 and 90, that gives us 180. So that means the sum of these two angles would be 180 in degrees, which is pi in radians. So the missing angle is going to be pi minus 1.2. Okay, so now we're going to use r theta. So 7.2175 is r and theta is pi minus 1.2. For pi, you're going to use the pi key in the calculator. Okay, this gives 35.1 in the end, which is the rounded answer.